Alright, here's a little update, two-part. First, what I have going, and I'll show it. So back to this schematic that I thought of, and it's very interesting. I don't know what it's doing. It's way beyond me. It's all over the place. So I made a rotor with 4 same polarity magnets, and I hooked. If you remember, it comes out of here. The direct current comes up through the bridge rectifier, out the DC port, into a boost converter, out of the boost into the negative side of the bridge rectifier, into the H bridge, out of the H bridge back into the DC source. Now out of the H bridge we get an amplified leg. Amplified leg comes out from the boost, and then it goes into a coil, out and back into the positive. Now people, we know that'll work because you're boosting it back into the positive. It definitely works. Back EMF comes from the choke, back out, back through the same circuit, and boosts. So you get more action there, was the assumption. Okay, so I hook it here and it works, no problem. I hook it here, I take this lead and connect it here, so the return of the coil goes right to the input, the direct current input coming out, and it works perfectly fine. Yeah, it works. You could send it right back to the boost converter itself. You could take this and you could connect it to this leg of the H bridge, the positive, and it works, no problem. Now you don't want to connect, I could connect it to the negative of the boost, and it works. But I don't, and I can't connect it. I can, but I don't connect it here, because if you connect this to here, it pretty much just makes a dead short. Why it does that, let's see. It comes out, goes over to here, comes out, and goes right into the negative, real high amperage, and it'll turn, but it's just going to burn everything up. It's just way too much amperage. It's no good. So as far as amperage reading, efficiency reading, this, I got the wrong kind of hall sensor on. I can't turn this hall sensor on and off. This is like always powered because the direct current's just coming through here the whole time, and the back EMF is pulsing, so it's all awkward. It's very fidgety. But I'm just showing an update that it's quite interesting circuit. It does interesting stuff. So yeah, let me get to it and show you what that's all about. Okay, so I have a rotor with all same polarities, one driver coil. Okay, it's working. I don't really know what's going on. Anyway, this is the amperage going to the driver coil. This is the amperage from the supply. 0, 0, 0, 0. Then it goes up a little bit. It goes back down to 0. I don't really know what's happening. Okay, here's the boost converter. Now, I got the power supply hooked up right to the AC side of a bridge rectifier, out of the bridge rectifier into a boost, positive side, out of the boost, goes through the multimeter and goes into this wire of the drive coil. This is the negative ground of the drive coil, so I'm going to unhook it. Okay, this is the negative of the coil coming back out. Okay, and I'm pulling no amperage really, and the motor's not going because I'm not completing the circuit. Now I could connect this right to the power. I could return it. This is a diode, only allowing it to go back. I could connect it right to the power supply hot lead, the ground to the power supply. Okay, and the motor goes. Watch. The motor goes. Sends current right to the power supply hot lead. Okay, I could ground it right to the positive of the bridge rectifier. and the motor goes. I could ground it to, I can't ground it here because this is the same wire that comes into the thing. I could ground it right to, well, the AC side here of the rectifier goes to the hot leg that goes to the H bridge, and obviously I could ground it there and it goes because that's the same as the AC side. And I can ground it right to the negative of the supply, but it goes, but I short circuit the whole thing and I pull a massive amount of amps. I'm going to blow stuff up because I'm basically connecting the power supply right to itself. But basically I could connect this almost anywhere and the motor goes. Now what's happening in here, I don't know. I'm using a choke. The schematic I'm going to upload, show you what's going on with that. But anyway, it doesn't run itself, but there's definitely a big increase in voltage from back EMF, and you could do all types of funky stuff with it. Yeah, so a little lost with the whole setup, but it's quite interesting.